Recording. Okay, your guys' homework. Answers. That should have been 25 and 8. I need to come up with some numbers here. 3.2 squared. And this one is 10.24. This one is 14.9332. 100. This one should be 1.3454. Sukman, good morning. Sukman, what's a piece of entertainment you'd like to forget so you can re-experience it for the first time? Think about it. This one's going to be 125. This one's going to be 3. This one's 3.0000 something. I want to cube root that thing. Cube 27.001. 4. Should be 4 zeros and then a 4. 13.4 cubed. Oops, nope. 13.4 cubed. This one should have been 2406.104. And then 3 over 7. This one's going to be 27 over 343. Okay, that's what you should have had up there on the top. These guys, you're going to get 1 and -1. Oh boy, the cube root of 1728 is 12. This one's going to be -4. This one is 10 plus, I don't remember what that one is. 729 is 9. It's going to be 19. This is going to be -5 plus 2 is equal to -3. Cube root of 2744. Yes, thank you. 14, that's a 7. Adding those, and then we're going to take away -3. So that should be 24. This guy is going to be -5. 216 is 6. -6. So this is going to be -1. -6 minus -5 is -1. And then down here, we're going to have 14 times 7 divided by -2. And over here, we're going to have 4 times something big. Thank you. Plus 2. So this one's going to be 66. And this one's going to be 49. -49. Okay, so there are ones on here that I should expect you to be able to do without a calculator. Things like this is not unreasonable for me to expect. Should I toss it to you? Even this one. Things as big as this, I would not expect you to know the cube root of 2,744 is 14. But there is stuff on here that I could theoretically expect you to be able to do. Okay, today, let's finish this chapter up. An application of exponents and bedmass is a theorem that you guys would have been introduced to back in the day, the Pythagorean theorem. Hands up if you recall the Pythagorean theorem. 3 of you, 4 of you, okay. So either your math teacher didn't do a very good job, or you've forgotten, or it's just too early and you can't be bothered. I'm not sure which it is, but it's one of those. You know of its existence, but not what it is. Okay, well, that's a thing too. Okay, so Pythagoras, this guy was, I'm going to insert a word here, allegedly, how do I spell allegedly properly? Ellegedly. Allegedly. We don't actually know. Lucas, do you have this booklet? Or do you need the exponents package? You have it? Okay. We don't know if Pythagoras was an actual person or if it was a group of people. We do know that the Pythagoreans, those people actually existed. And oftentimes in ancient times, what they would do is they would collect themselves around a specific teacher. So guys like Socrates, guys like Plato, we know these guys actually existed. They would have students that followed them. Like Socrates was a student of Plato, and Socrates had his own students that we know about now. But we don't know whether or not Pythagoras was actually a person or whether it was just this group of people. But again, we assume that this group of people gathered around one person. Was allegedly a Greek mathematician. And this group, one of the results that came out of this group was that they found that the square of a hypotenuse of a right-angled triangle. So there's some language in here. This is a right-angled triangle. It's a right-angled triangle. Why? What does it mean for it to be right? Sorry? Nope. Sean? One angle is 90 degrees. So this angle right here, that being 90 degrees, makes this triangle a right-angled triangle. And the hypotenuse is always which side of that right triangle? Who remembers? Which one of those sides is the hypotenuse? I mean, when you say the angled side, you mean that guy? In this case, that's technically true. What if I made it not angled? What if I made it flat? Would it still be the hypotenuse? Because now the other two sides are angled. When you say angled, what do you mean? The one side that's not touching the 90, yeah. So the hypotenuse is always the side across the triangle from the 90. That is the hypotenuse. And in the Pythagorean theorem, as it's taught to you guys in middle school, this side always has a particular letter that identifies it. We call this side C. And it's a lowercase c, because that's important. If this is side C and it's the hypotenuse, the other sides that are not hypotenuse, we call them legs. Does anyone remember how we label the legs? I mean, if one of the sides is C, then it would make sense that the other two sides are labeled A and B. It does not matter which one's A. It does not matter which one's B. The hypotenuse has to be C. So I could call this one A. I could call this one B. Or I could go the other way. I could call this one B. I could call this one A. It doesn't matter. One of them's A. One of them's B. You make your decision. You roll with it. Lucas, what I got? You gotta pick one. So I'm gonna call. We're gonna force this in here. Lucas, I want to see your eyes. We'll call this guy here A. We'll call this guy here B. And a result that the Pythagoreans found was that the square of the hypotenuse of a right-angled triangle is equal to the blank of the squares of the other two sides. Interesting. The square of the hypotenuse of a right-angled triangle is equal to the sum of the squares of the other two sides. And that's kind of a long, sort of convoluted way to say the following. I'm going to redraw this. Over here. I'm trying to draw the same triangle. And what they found was, when we talk about squares, I want to bring back literal squares. They actually had squares here. And so when we were making squares off of this triangle, what they did was they said that each one of these sides of a triangle represents the sides of one of these squares. So I'm going to draw this square here. We have a big square. We have a little square. And we've got a slightly larger square. And what they found was, if I take this area here and this area here, and I add it together, every time for every right-angled triangle, it's going to equal the area of this square here. It's a neat little mathematical relationship that they discovered, and it holds true for every right triangle. Now the question is, how do we get these squares? How do we find the area of a square? We did it yesterday. Area of a square is? Length times length. So if this side here has a side length of c, then this area of the triangle is going to be c times c, which is, in exponential notation, c squared. C times c is c squared. Well, and if this side over here is a, and this side over here is b, then the area of this triangle is going to be, a squared. A times a is a squared. And b times b over here is going to be b squared. And what they found was that adding these two together gave you every time this area, which is interesting. And so rather than the convoluted sentence that they give, because if you translate it directly from the Greek, this is what it says: the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other two sides. You draw it out like this, and all of a sudden we can start to simplify the arithmetic. It's a squared plus b squared equals c squared. A squared is this area, b squared is this area. You add them together, you're going to get this area, c squared. And we can use this equation to start finding things we don't know. Stuff that you were supposed to do in grade 8. If we know the hypotenuse but missing one of these short sides, like I said, I wanted to solve for this. So if I know a and b, I can plug a and b here in here, and I could use this to find c, for example. But if I know a and c, then I could plug this in here, and I could rearrange one of these. I could rearrange this equation. I could use the following equation. I could say that c squared is equal to a squared minus b squared. Nope, that's not true at all. Ugh, delete off. It's too early on a Friday morning. C squared minus a squared equals b squared. That's what I wanted to write down. Come on, delete off. Alternatively, c squared minus b squared would also be equal to a squared. Either one of these two equations or this equation here can be used to find unknown sides in a triangle like this. And I'll do a couple examples and I'll show you what I mean. So I've got these two examples here. I've got this triangle. This triangle has a side length of 2, a side length of 3, and we would like to know this side here, the side that's labeled with a question mark. Now, before you start any of these questions, it's important to label them properly. You always want to label the hypotenuse first. Which side is side C? The one with the question mark. Sweet. So if that's C, that means this is A and B. So then, we're going to use a squared plus b squared equals c squared, and I'm going to go over here so I have some more room to write. A is 2, the way I've labeled this. B is 3, the way I've labeled this. So we're going to take these two values and we're going to plug them into the Pythagorean theorem. We're going to get 2 squared plus 3 squared equals c squared. And I want to find out not what c squared is, but what c is. So we can do some bed massing here. A squared is plus 3 squared, which is, that's going to equal c squared. So c squared is going to equal 9 plus 4, which is, well, one more time, 13. So c squared is equal to 13. I don't want c squared, I want just c. So if something squared is equal to 13, how do I find what that something was? What's the opposite of squaring something? Square rooting it. So to find out what my side length c is, I'm just going to square root both sides. On the square root of c squared is just c. We did that yesterday. and the square root of 13, this is what you would be allowed to punch into your calculator. If you do that, you're going to get that this is going to be 3.6. I'll give you some more decimal places on that. 3.6056, which we could round to 3.6. I'll give you the 4 decimal places and we'll round it. So how long is this side? Well, if that one's 2 and this one's 3, this one has to be 3.6. For how many of you is this ringing bells of stuff you did in grade 8? We're really hoping for more than 4 of you. Okay. Let's do another one. I got this guy here. I've got 9 on this side, a 5 on this side, and a question mark on this side. So let's label these things. Which one of those is side C? The 9. Again, remember, you always want to go across from the 90, and that's going to be a 90. That hard corner there is the 90. So now, if I've got, and I look here, I've got a side length for C. Let's call these A and B. Again, it doesn't matter which one you call which. And now we're not looking for C anymore. We're actually looking for B. So which of the boxed equations above are we going to use to find B? Jacob, was that your voice? No, it wasn't Jacob. Yeah, we're going to use C squared minus A squared equals B squared. And now we're going to fill it in and solve. Let me go up here just so I have some more space. So C is 9, so we're going to have 9 squared minus A is 5. 5 squared equals B squared. 9 squared is 81 minus 5 squared is 25. And notice there are no brackets that include that minus sign. So the 5 gets squared without that negative. So I'm going to get 81 minus 25 is 56. So 56 is going to equal B squared. I don't want B squared, I just want B. So what do I have to do to get B? I have to square root. So B is going to equal the square root of 56. And I'll give you that value. You should all have your own calculators, but you don't. 7.4833 is what it rounds to. So I would round this thing to 7.5 equals B, and there's our value. The length of the missing side is 7.5. Comments, questions, concerns? It's not overly complex, I don't think, but it's just an application of exponents, roots, and bed mass. Okay, what time does this block actually end? Can I do a little bit more? I would like to do a little bit more. Ha! Block ends at 10:25. I can totally do some more. So, what I'm going to get you guys to do, I want you to flip the page over, and I want you to do the following. I'm going to give you 10 minutes, and then I'm going to move on. I want you guys to do B. I want you guys to do C. And I want you to do D. B, C, and D. Take a look at those 3. And I will come around and assist. What's up? Yeah. It does not matter. A and B can be labeled interchangeably. The only one that matters is that the front is. Which would be directly across from the 90. It doesn't work anymore. Leave it open. You keep missing them. Well, I'm almost out. Pretty soon, I am not going to have writing utensils for you guys, and you're going to be on your own. You don't have a calculator? Exchange your phone for one of mine. Otherwise, it gets a little difficult to do these. At least that final second. Yes. Okay. What was your answer to the side length for B? How long is that side right there? 50. Love it. How about this guy right here? That is 6. And side D is 12. I heard someone say that is correct. Love that. Okay, I am going to give you, if you'd like more practice, you can do these other 3. I won't tell you what the answers are exactly. I will tell you that one of them is 8. I will tell you that one of them is 31.6. And I will tell you the other one of them is 16.9. I won't tell you which is which, but if you want to do the other 3, those are the answers you're looking for. I want to do one of these with you, and then I'm going to leave you the rest of the day, the rest of the block rather, will be probably 20 minutes after this, to work your way through some word problems using the Pythagorean theorem. I've also got, once I'm done my one example, I have your chapter reviews for the exponents chapter for this chapter we've just done. Your guys' chapter test is going to be on Tuesday. So you'll have the weekend and Monday to review for it. I think your test will be Tuesday because I'm not going to give it to you on a short block Wednesday, Thursday, and we don't have school Friday. So next Tuesday is your chapter test. Here we go. So I have a question here. The bottom of a ladder must be placed 2 meters from a wall. The ladder is 6 meters long. How far above the ground does the ladder touch the wall? So when you're given a question like this, there is no picture. And so what it would make a lot of sense to do is to actually draw a picture. There's a wall. Here's the ground. And now we're going to slap a ladder in there. Here's my ladder. There's the ladder in there in green. And what do we know about this scenario? Assuming the building has been built properly, that's going to be a right angle triangle. What does the information in the question give us as far as usable information? It says the bottom of a ladder must be placed 2 meters from a wall and the ladder is 6 meters long. So those two sentences tell us what? Which line have I drawn there is the ladder? The green one. And the ladder is what? 6 meters long. So that means that this green line here must be 6 meters. 6 meters long. If the ladder is, there is my ladder. What side is this in the triangle here? Sorry? That's C, that's the hypotenuse. We're also told that the bottom of the ladder must be placed 2 meters from the wall. And we're asked to find how far above the ground the ladder touches the wall. So what side here do we know? Sorry? Well, I still have to put this 2 somewhere. Where's the 2 going to go? Jacob, louder. The bottom. The distance from the wall to the edge, it says the bottom of the ladder, there's the bottom of the ladder, must be 2 meters from the wall. So this is going to be 2 meters. And it doesn't matter if I label this A or B. So let's call it, someone said, let's call it B. And what are we looking for? We want to know how high above the ground that ladder reaches. So that there is A. So then which of the equations are we going to use? And these are written in a slightly different way than I first gave them to you in. I'm going to go back and say that, let's rewrite this one. C squared, I'm not going to give them to you like this. That's not how I'm going to give them to you. I will give them to you, but it's going to be C squared equals, or C squared, sorry, minus B squared equals A squared, and I'll give you C squared minus A squared equals B squared. And I will expect you to be able to solve those ones. So which of those equations are we going to use? The way we've labeled it, if this is C and this is B, we know these two things. I'm going to use this guy here. C squared minus B squared equals A squared. So let's fill it in. Hypotenuse is 6 squared minus 2 squared equals A squared. So this is going to be 36 minus 4 equals A squared. Let's go this way. 36 minus 4 is 32 equals A squared. To solve for A, I'm going to square root. So how long or how high up the wall does that thing reach? What do you get? Let's see, a bunch of calculators going. This is good. Sorry, Carson? You have a calculator? Why don't you have a calculator? How did you do the 3 previous questions over the 10 minutes that I gave you if you didn't have a calculator? What's the square root of 32? Hello, Bilal. When did you sneak in? 5.65. So let's round that to 5.7. A is equal to 5.7 meters up the wall. So for these ones, draw the picture. Got to try and decipher what's going on there. Some of them I gave you a picture. For question 2, I gave you a picture. Tells you how long the football field is, how wide the football field is. You guys don't even know who Mr. Abraham is because he's not here this year, so let's change this. Who's your favorite PE teacher this semester? Mr. McDonald, okay. Wait, Mr. McDonald doesn't teach PE. He's a PE. Who's Mr. McDonald? Is it MAC? Or is it MC? Mr. McDonald, okay. I did not know we had a PE teacher here named Mr. McDonald. He allegedly is the best PE teacher. Gives you the option of running 1 lap around the perimeter of the field or the diagonal 3 times. You got to figure out which of those distances is the shortest. And I've got some more questions. There's a TV. Mr. Easton bought a TV. Gurman is flying a kite. And Taylor, who is not in this class, leaves her house to walk to school. This is the end of the exponent section. That is what I'm going to give you to work on today. I'm also going to go down to the photocopier right now and grab my reviews that hopefully didn't jam the copier. You have your task on your mark and set go.